after the solving, let's think about the sketching. Okay, think about the sketching. To sketch a log is a little bit complex than sketch for exponential. Well, log graph, well, the basic one is log EX. Well, we can log 2x, log 3x, or log something x. The graph looks like that. Okay, the graph looks like that. And we have a vertical asymptotes. Okay, you can't really see it clear there, but there's a vertical asymptotes. Use a nice color. Okay, you have a vertical asymptotes at x equals to 0. Why we have vertical asymptotes at x equals to 0? Because 0 is almost the last point. You can't really take 0, but after 0 we can take it. That's a line to distinguish the domain. Okay, on the right hand side the domain is possible, left hand side the domain is not possible. It's more like a line to separate the Cartesian plane and tell you which part is the possible part, okay, to take the domain. So first of all, we talk about the general equation for log. This is the general equation for log. Okay, as I said, for exponential, remember for exponential, the horizontal movement b is useless. As I said, when you sketch for it, you don't need to worry about that b. So in this case, the c is useless. Okay, you don't need the c value to sketch for graph. Okay, you don't need to look at that c. After you find all the key point, the shape, like you already cracked. Okay, the c won't affect too much of the graph. So it's only move up and down, not going to change the direction of the graph. Okay, the next thing is, how do we sketch for it? Okay, still follow all these steps. Okay, still follow all these steps. Step number 1 is, well, think about log exponential. The first thing is we find asymptotes. So step number 1 is still find asymptotes. It's a vertical one. Okay, it's a vertical asymptotes. How can we solve it? Exponential is very easy. It's y equals to c. It's the last value we can see, the adding or subtract value. For log, it's a little bit complex. We need to solve the thing in the bracket to be 0. The log bracket equals to 0. And solve for x. That x value will be the vertical asymptotes. You solve log something, that's something to be 0, and see which x will give you 0. Then that value is the vertical asymptotes. That's the first thing. Well, second one is really similar to exponential now. Choose a base shape. A basic shape. So you have two basic shapes. One is the base greater than 1, and one is the base in between 0 to 1. Still increasing or decreasing. So when it's greater than 1 is increasing graph on the right hand side of the asymptotes. When it's in between 0 to 1, it's still on the right hand side, but it's a decreasing graph. Okay, it's a decreasing graph. You select. Okay, you see the base and you select. Okay, number 3. Number 3 is see the reflection. Reflection. Okay, still have two reflections. The reflection will be the a value and the k value. When a less than 0 and when k is the coefficient of x, and when k less than 0. A less than 0 is a horizontal reflection. And when k less than 0 is a vertical reflect. Okay, it's a vertical reflect. Okay, for exponential, do we definitely have x-intercept or y-intercept? For exponential, will we definitely have vertical x-axis or y-axis? Sorry, x-axis or y-axis? Which one? Which one? Will we definitely have x-axis? Will we definitely have y-axis? How about intercepts? Which intercept will definitely have? X or Y? For exponential. Y-intercept, right? The domain is R. I definitely have X equals to 0. But, you know, like exponential and logarithm, they are, what is it called? Inverse graph. Okay, inverse graph. Because exponential will definitely have Y-intercept. Therefore, logarithm will definitely have X-intercept. So the number 4 will be find X-intercept. You will definitely have X-intercept. Okay. Doesn't matter what log, you definitely have X-intercept. Your Y can always be 0. And then number 5 is find Y-intercept if possible. Find Y-intercept if possible. So that's how we sketch for it. Basically the same as how we sketch for exponential. But you know there are inverse functions. The domain and range will swap. So therefore, the range for log is R. Because the domain for exponential is always R, right? There's no restriction on domain. So the range for log must be R. Okay, domain for log must be R. Unless the domain is restricted. Otherwise, the range is always R for log. Doesn't matter what log equation you have. The range is always R because the domain for any exponential will be R. So that's why the range always be R. And the domain will be not really R plus. R plus is only for log AX. We can solve for the domain. So how do we solve for the domain? We solve the domain by solving this inequality. Is the thing in the bracket to be greater than 0. So the thing you put into log must be greater than 0. So that's how you solve for your domain. Okay, that's how you solve for your domain. So that thing to be greater than 0 is the domain. Or you can see from the graph. Okay, let's have a look at the equations. Okay, let's sketch 2 and 4 first. Okay, step number 1, we find asymptotes. To find asymptotes, we make 2x minus 4 equals to 0. My pen's not working well. 2x minus 4 equals to 0. So x equals to 2. Okay, x equals to 2 will be my vertical asymptotes. Okay, that's the first thing, x equals to 2. That's my vertical asymptotes. Step number 2 is to select a basic shape. Okay, we look at the base. The base is E. Okay, what's the approximation value for E? 2.7, which is number greater than 1. So we will select our basic shape as an increasing shape. Okay, on the right hand side of the asymptotes, but it's an increasing shape. Well, the third thing is to look at if there's any reflection. If there's any reflection. Can you see any reflection? Yes or no? Which direction you should reflect it? Horizontal or vertical? Horizontal, because you have this minus 3 here. It's a horizontal reflection place. So we reflect it horizontally. Looks like this. Okay, it looks like this. So, well, the shape of the graph will be this. Okay, the shape of the graph will be this. But we need some point to help us. So 4 is to solve for the x-intercept. So y equals to 0. 0 equals to minus 3 log e 2x minus 4. So 0 equals to log e 2x minus 4. 2x minus 4 equals to e to the power of 0, which is 1. Okay, e to the power of 0, which is 1. So 2x equals to 5. X equals to 5 over 2. So 5 over 2 here. And you know it's a decreasing shape. I can't find any y-intercept. Okay, the shape looks like this. Well, I can find another point. For example, I find that point, which is 5, negative 3 log e 6. Just give any point. Okay, just give any point. I need 2 points on the graph to sketch it. So, well, because you have base e, you can't really have some accurate number like 5, 2, something like that. So you will just leave the exact form. Okay, so it's negative 3 log e sub 5 in, you have 10 minus 4, 6. So that's how we sketch for log. Then what's the domain? What's the domain for this question? See from the graph, what's the domain? Not that hard. 2 to infinity, not exclusive. Okay, 2 to infinity, not exclusive. 2 from the right hand side. Okay, that's how we sketch for log. Okay, if you can look at number 4. Okay, if you can look at number 4. Okay, number 4 is y equals to minus 3 over 2 log 0.3 negative 2x minus 3. So step number 1 is to find the asymptotes. So it's minus 2x minus 3 equals to 0. What's wrong with my pen? Minus 3 equals to 0. So minus 2x equals to 3 and x equals to minus 3 over 2. Okay, minus 3 over 2. Let's sketch for it. Minus 1.5, which is here. X equals to minus 3 over 2. And then the second step is we choose a basic shape. Okay, the basic shape we'll look at is the base. Base is 0.3. 0.3 is in between 0 to 1. Therefore, we'll have a decreasing shape. Okay, we'll have a decreasing shape. Do we have any reflections? Do we have any reflections? We have negative coefficient here. So it will be reflect twice. Okay, it will be reflect twice. So let's say let's reflect by negative 3 over 2 first. Reflect by negative 3 over 2 is reflect by horizontal. So that's because A equals to negative 3 over 2. That's why we reflect in horizontal. And then reflect in vertical. You have that. That's because k equals to -2. That's reflect in vertical. Okay, we have that. So actually we should have a shape looks like this. Okay, look like this. But I need to find the intercepts first. So we make y equals to 0. So log 0.3 minus 2x minus 3 equals to 0. You see minus 2x minus 3 must be 1 because 0.3 to the power of 0 is 1. Minus 2x equals to 4. X is minus 2. So x is minus 2. Which is this point here. Okay. How to label the point? That point is 5 over 2 comma 0. That point is minus 2 comma 0. Well, that's 0.3 to the power of 0, which is 1. Okay, now I want another point. I can't see any y-intercept, so I need to find another point. So which point I will select? Well, I will select a point easy for me to calculate. Think about that. If I can make minus 2x minus 3 equals to 0.3, why I choose 0.3? The base is 0.3. If I can make inside to be 0.3, that log will become 1, right? The whole log will become 1. That's why I choose this point. Well, which x can give you 0.3? So minus 2x equals to 3.3. Then x equals to minus 1.65. Okay, minus 1.65. So when x equals to minus 1.5, y will be minus 3 over 2 log 0.3, 0.3. So y will just be minus 3 over 2. Okay, so the x value is that, y value is that. So I want to choose a value easy for me to calculate. I can make sure which point I will label. Well, not necessary. You can just substitute any point and to get a point which you can't maybe simplify. Just leave the answer as the exact form. That's fine as well. But because when I do this, I can make sure another point, where is the other point? Also, I can test whether my shape of graph is correct. Okay, I can test whether my shape of graph is correct. So minus 1.65. Which is here, and minus 1.5. What is here? Minus 1.65 and minus 1.5 is here. So the shape of graph is like this. So this point is minus 1.65, comma minus 1.5. Minus 2, comma 0 here. Okay, you can see the domain of the graph is minus infinity to minus 3 over 2 exclusive. Okay, that's the domain. Okay, you go to complete the 1 and 3 by yourself as homework, and we can check answer at the start of next lesson. Any questions? Okay, that's it.